Hey guys, in this video I'm going to show you how to answer every single question that appeared in paper 2 of the Year 6 SATs 2025. Question 1. Circle the angle that is closest in size to a right angle. So here it's looking for your understanding that a right angle is a 90-degree angle. You may use a protractor to measure them all, or you may be able to recognise from sight which one looks closest to a right angle, which is this one. Make sure you circle it, which is what the question indicates you to do. Question 2, write the two missing numbers. So you can see that we have part of a chart with some values indicated and two spaces where our two missing numbers are. We've got some clues. From left to right in that direction, numbers increase by 1,000. So from 5,350 to 6,350. 5,450 to 6,450, 7,450. So numbers increase by 1,000 when they move from the left to the right. You can also see that from going from top to bottom, numbers increase by 100. So we've got your 5,350 increasing to 5,450, 6,350 increasing to 6,450, etc. And so we're going to use these clues to find our missing numbers. Now I would actually start with the second value. I'd start with my 7,550 increasing by 1,000. So all I've got to do is add 1,000, just change the value of 7 in the 1,000 place by 1. So that becomes 8,000. The rest of the number stays the same, 550. And now I'm going to go back to the other missing value where we have to add 100 going from top to bottom, but we don't actually have a number above it. So we're going to have to reverse. We're going to have to decrease by 100 to get to 5,250. You can see 5,450, 5,350, 5,250.
How much more money does Layla have than Adam? So pay attention to the fact that more is highlighted, and we have two amounts of money and written in coins. Now, if you're not familiar with coins by sight, then they are written on there what they are worth. So the first thing we would do here is we would annotate how much each person has. Layla has a £2 coin, a 50p coin, and a 20p coin. Now, you may be able to add that mentally, so that means in your head, or you might need to write it down. So you could write down a calculation. You could put £2 plus 50p plus 20p, and you could add that up. You could add it up like this. Remember, 50p is 0.50. Or you could just add it left to right. However you want to add it, whatever method you choose is fine. So I'm going to write this down as £2.70. £2 plus 50p plus 20p is £2.70. And then the same on the right with Adam's money. We've got 3 50p's and 2 20p's. So you can either write out the calculation, 50p plus 50p plus 50p equals 20p plus 20p equals, and add those two amounts up. We could do it in your head, 50, a pound, £1.50. And then we've got 40p here. You could be adding up in hundreds, so 50, 100, 150, 170, 190. So we've got 190p. Remember, this is £1.90. So however you do it is fine. Show you're working out. I'm obviously going to rub out for the purpose of demonstration. You will not be able to rub out on your, or you wouldn't want to rub out on your paper. Show all your working out on your paper if you can. So now we need to find the difference between the two. To find the difference, you might do a subtraction, £2.70 subtract £1.90, or you might use a number line, £1.90, £2.70. I'm not doing a straight line, I'm drawing on a screen. Hopefully you can do your working out much neater. So find the difference here. This is a difference of 10p to get to £2. And then from £2 to 70p is a difference of 70p. So that's a difference of 80 pence. Or you might have done £2.70, subtract £1.90. You would also, if you carried out that subtraction, get 80 pence.
Question 4. Match each point to its coordinates. So you can see that we have a grid with a shape plotted and we have 4 vertices labelled A, B, C and D, and we simply need to match each of the coordinates here to one of these letters. So how I would approach this is to go to each letter and write the coordinates. So if I go to A, and remember it's always along the corridor up the stairs, or we can go along the corridor left or right, and we can go up or down the stairs. So along the corridor, up the stairs, or up or down the stairs is relevant to one quadrant like this or 4 quadrants. So if we go to A, we go along the x-axis first, it's on 0 and then it's 3. So this is 0, 3. You could label it here, then match it up afterwards, or we could just go, okay, A is 0, 3, look, there's 0, 3 there, so we just match them up. B, it's at 2 on the x-axis and it's at 6 on the y-axis, so the coordinate is 2, 6. Again, you can label it there, or you can just simply find it and then match it up. D is at 6, then 2. So if we think about which ones could be mixed up, B and D could be mixed up if you are going up the y-axis before going along the x-axis. So D is 6 along the x-axis and 2 up the y-axis. So D, I know I've missed out C, but I've just gone around the shape. So that is something to be mindful of, that could have easily gone next to C because I've skipped C out and gone straight to D. If we go up to C now, that is 8 along the x-axis and 8 up the y-axis. You might label it there. And it's also the missing one. So you can check each one. A, 0, 3, B, 2, 6, C, 8, 8, and D, 6, 2. Question 5. Olivia counts in 8ths starting at 0. Tick all the numbers Olivia should say. Be mindful that the all is in bold. That means that there are at least more than one number, at least 2 numbers. Olivia counts in 8 starting at 0. So we're just using our 8 times table. Now if you needed to, you could start at 0 and just write the next few, 8, 16, 24. You would then realise, okay, I'm doing the 8 times table, I'm doing multiples of 8. So if we go down, you know that 24 is in the 8 times table, 42 is not because we have 40 and then we have 48, so I'm just going to put a little cross next to it. You don't need to put a cross next to it, just leave it blank. 78 is not a multiple of 8 because 80 is. So 112, if you are not sure if 112 is in the 8 times table, you could either put it in a bus stop and divide it, or if I know that 112, I would chunk it and either think about 80 being 10 eighths, and what would I add to 80? I can see there that it's 32, 80 and 32. So I know that that's 10 lots and that's 4 lots. So I know that that is in the 8 times table. Or you might think of the biggest 8 times table you know. So it might be 96, which is 12 lots. And 112, take away 96 is 16. And 16 is 2 lots of 8. So both ways, look, 14 lots of 8. So that is, or you could do it in the bus stop. 8 doesn't go into 1, 8 goes into 11 one time with 3 left over. 8 into 32 is 4, it goes in. It is a multiple of 8, so we tick that. There are 2 options here. That is all of the numbers that Olivia would count if she started at 0 and counted in 8ths. This is question 6. Both these questions they're both part of question 6 and they're worth 1 mark each. Note the bits that are in bold. Which digit is in the 100,000s place? And the second bit is what is 2,000 more than the number? So which digit is in the 100,000s place? You just need to be able to identify the value of each of these digits. So your ones, your tens, your hundreds, your thousands, your 10,000s, 100,000s, and your millions. So the 100,000s place is this, the 6. and it says which digit is in the hundred thousands place. So you don't write 600,000, you just write 6, because that is the digit that is in the hundred thousands place. Now it's saying what is 2,000 more than that number. If you go to the 1,000 column, 9 is in the 2,000 column, that is going to increase by 2. You can either do it like that, or you could write it out as an addition. 5,639,728 add 2,000. Okay, you're going to get the same answer either way. If you just are adding to the thousands column, I know that these bits are going to remain the same. It's just the 9 and the 2 is going to become 11,000. I'm going to put my comma in there, my separator. That's going to become 11. So the 10, so we've got 1,000 goes there, and the 10,000 is going to add to that 30,000. So that's going to become 40,000, and this is going to stay the same. So 5,641,728. If we look at just the thousand section, it was 639,000. It's now 641,000, which is 2,000 more. So if we just looked at the thousand section, we had 639 before, added 2 more, that's 641. That is just the thousand part of that number. Everything else stays the same. This is question 7. Here is a graph for converting kilograms and pounds. You can see along the y-axis is kilograms, along the x-axis is pounds. The line in the middle shows you what every kilogram is equivalent to in pounds, and vice versa. Use the graph to convert 5 kilograms to pounds, and use the graph to convert 7 pounds to the nearest kilogram. Now for this, a ruler is ideal. I don't have a ruler on my screen, so I am going to just do it freehand. So 5 kilograms is here. So if I went along the line, it's going to go to there, and then I'm just going to go down to 11. So it is 11 pounds. The 5 kilograms, if I go across the line and then down, it is 11 pounds. If I use the graph to convert 7 pounds to the nearest kilogram, remember 7 pounds to kilograms, I need to go from the pounds bit. I'm going to go from here up to the line, and then if I went along using a ruler, it's going to be there. Now it says the nearest kilogram. You can clearly see that it's less than halfway between 3 and 4. Okay, if we zoomed in, it's a little bit past 3, it's quite away from 4. It's closer to 3 than 4, so the answer would be 3 kilograms. Question 8. Draw the reflection of the shaded shape about the mirror line. Okay, so this about the mirror line just means across the mirror line. So we are using a mirror line to draw a reflection. For this, you absolutely need to use a ruler, and you just need to make sure that you plot all your points very carefully. There is a little bit of a margin for error. Your examiners will have digital screens where they can zoom right in, they can measure. So be as accurate as you can, use a sharp pencil, and make sure you use your a ruler with both hands, so you're very stable. Now I'm going to do a big thick line. You're not going to do that, but just so that you can see a bit clearer. So I'm going to plot my dots first, so that corresponds to this dot, then this. If you do each point first before you join up, you're less likely to make an error. Now I'm going to do this part. So you're just going to make sure that you put it on the reflection, so you can see this part here is the top of that semicircle, so it goes here. It is very easy to make a mistake with these. Now, especially with this bit at the bottom, it can be very tempting to put your line in the corner there, but if you look at this point here, it's actually at the bottom of this semicircle. So if we go across, it's at the bottom of the semicircle. So just check each point. There are 4 vertices. Check each point is correct before you draw your line in. Make sure that it is a straight line, that you don't draw lots of lines, you don't draw loops, and then join each one up carefully. So if I start from this line, I'm going to go straight across. I've actually just redone that slightly thinner. Now I'm going to go from there up to that point, from there down to that point, and then from that point to that point. So your finished shape will be a reflection of this shape on the left hand side. So my advice is to plot each of the vertices first, and make sure you use a sharp pencil, and make sure that you're holding your ruler really still, and then join up all your dots. Question 9, there are 2 parts to this question. Each part has 1 mark. Ali has 3 red counters, Ali has 35 red counters, and he divides them into groups of 3. So I'm just going to highlight that. What is the greatest number of groups of 3 he can make? So greatest is in bold, so we need to make sure we think about that. He divides them into groups of 3. So we are doing division, we're thinking about multiples and factors here. So if we think about multiples of 3, what is the greatest multiple of 3 that gets up to close to 35? Or if we divide 35 by 3, what do we get? So if I do it the first way, 35 divided by 3, using your 3 times table, you should know that it is 11 remainder 2. Okay, so 11 3s are 33 with a remainder of 2. If you were counting up in your 3s, you would get to 33, and then we know that 36 is too big. Okay, so it can't be 36 because 35 counters. So either way, you would know 33 is the greatest amount of counters we can count. But if we think about how many groups of 3 that is, it is 11. Okay, so it's 11 groups. We can do 11 groups, and then there'll be 2 counters left over. Maria has, so the second part, Maria has 35 green counters, and she divides them into groups of 4. So this time we are working with multiples of 4. So again, how many green counters does she have left over? You could do it as a division. I would do it as a division. 35 divided by 4. You're using your 4 times tables. It is 8 remainder 3. I know that because 8 times 4 is 32. So you might count up in your 4s until you got to the closest number to 35, which would be 32. That's 8 lots of 4 with a remainder of 3. In this question, it's asking what she has left over. So that is the remainder part of your answer. 3 left over. Question 10. Olivia is making a cube from a net. She wants the cube to have 2 circles on opposite faces. Draw 1 circle to complete Olivia's net. So for this, you need to be able to visualize how this net folds up to make the cube. So you can already see that we have this side and this side connected to the base. So we can think about the circle being on the base. We know they're going to fold up to make sides. If I colour code it, I know that this side is going to connect to there. Once it folds up, that blue bit there is going to connect to the bottom there, and this bit is going to connect to this bit. So this one, this one, this one, and this one are going to be the sides of this cube, okay? Which means that this last one that I haven't identified yet, this one, is going to be the lid. That's going to be the lid. So that is going to be opposite. So that would be where your circle goes. So you would draw your circle there. Question 11. The total distance from Paris to Munich by road is 860 kilometres. There are 3 sections. The distance for the first 2 sections are shown, and then you have a route mapped out with 2 of the sections shown. How many kilometres is the last section from Stuttgart to Munich? So some important bits of information is that the total is 860, that we only have the first 2 sections. We know that the first 2 sections equal to this. We know that all 3 will equal 860. We have to figure out what this last section is worth. So there are a couple of ways you can do this. You can either add these 2 together to find the total of the route so far, and then find the difference to 860, which is the same as subtracting it from 860, or you could do 860, subtract the first bit, 331, then use that answer to subtract the second bit. So I would add up the first bits. You do need to show your working out. It's very important to show your working out clearly. Okay, so add these 2 bits, make sure you write an addition sign, put in your equals signs. I haven't got a ruler on this, so just very clearly add it up. And then we need to show that you understand that you're finding the difference. If you are finding the difference, please just write it, even if you're using find the difference as a method, like using the bar model or something like that. Draw your bar model clearly, or if you're using a number line, draw your number line clearly, but just at least write that you are doing 860 subtract 626 next. Okay, don't just do it in your head and then write the number, because you may miss a method mark if you get the final answer wrong. How I would suggest you do it is to do the formal written method, which is to subtract it like this. However, it is absolutely fine for you to use a different method. Just please show your intention that you are doing 860 take away 626 and show how you've worked it out. Try not to do things in your head unless you are absolutely 100% certain you will not make a mistake, just because you may miss out on an important method mark. With this, even if you got this wrong now, you'd get a mark, because based on previous mark schemes, things can change, but based on previous mark schemes, you'd get a mark even if you got this final answer wrong and then you put that answer in the box. Okay, so you're just going to subtract now and write the answer in. Make sure you write the answer in correctly. If you do not write the same answer here as here, the examiners might assume that you've done something else, so make sure whatever you write in your box is what you intended to at the end of your working. Question 12. Amina says 600 millimeters is longer than 1 meter. Amina is not correct. Explain how you know. So for these types of questions where you have to explain, you're just going to prove the statement is not correct. Okay, so you don't need to say Amina is not correct because 1 meter is shorter or is longer, sorry. You don't just sort of repeat what the question says in different words, you have to actually prove it. Now, to prove it, the things we need to notice are that we have 2 different units of measurement. If you have 2 different units of measurement, it means that you need to show them in the same measurement. So you can either change both to millimeters or you can change both to meters. You don't need to do both, and sometimes people do the right answer in one unit and then they change it to the other unit as well, and then they do the wrong answer. If you've got a correct and an incorrect answer inside this bubble, you won't get the mark. So you must make sure everything inside, don't try and put too much in there. Once you've proven them both as millimeters or both as meters, just stop there. You don't need to do any more. It can be as basic as saying 600 millimeters is equal to 0.6 meters. That's enough to get a mark. You've converted one to the other. You could also have just said 1 meter is the same as 1,000 millimeters. What is really important is that if you are abbreviating like I've done here, M is meter, MM is millimeters. If you write these wrong, if you write centimeters or you just write 1M for millimeters, you will not get a mark. So, or you can write out the units as is there. Please be careful not to write milliliters or kilometers. That has been done. So something like that is worth a mark. Or just showing, a lot of people will sort of say there's 10 millimeters in 1 centimeter. That's fine if you want to show you're working out, and 1 centimeter, 100 centimeters equals 1 meter, therefore 1,000 millimeters equals 1 meter. None of that matters. The only bit that gets you the point is showing the meters as millimeters. Okay, so as long as you have shown that either what the 600 millimeters is as a meter, which is 0.6 meters, or what a meter is as millimeters, which we've done here, that will get you a mark. You can show all your workings out in here. You can write it in words. You could write it in mathematical figures. A lot of the times after this bit, people will write 600 millimeters is less than 1 meter. That's absolutely fine to do. That bit works. Or people might write 600 millimeters is less than 1,000 millimeters, because that is, sorry, look, can you see I've written meters there instead of millimeters? That would make that whole answer incorrect because I've done the abbreviation wrong, so you must check it. 600 millimeters, which is in the question, is smaller than 1,000 millimeters, which is also in the question. So that's showing it's not longer. She's saying it's longer, I'm saying it's shorter by using that symbol, the less than symbol. I can use that because I've already proved here that 1,000 millimeters is 1 meter, or I've proved that that's what I know. I've shown what I know. All of that is okay to get a mark, but you must make sure that you have both of these numbers in the same unit, either both as meters or both as millimeters. And don't write anything additional in here that is incorrect. Question 13. Jack buys 4 concert tickets. Each concert ticket costs £28. Tick each calculation that Jack could use to work out the total cost, and one has been done for you. So 4 lots of concert tickets, and we want to figure out what calculations would work out the total cost. Each ticket's £28, so essentially we have 4 lots of 28, or 28 lots of 4. Okay, both of these would work out, they're the same thing, but both of these would work out this calculation. So that would work out the total cost. In this first one, 28, 28, 28, and 28, this is repeated addition. This is the same as 4 times 28 because it's 4 lots of 28. I would say that the multiplication symbol, you could change the word times for lots of, so 4 lots of 28. And in that first sentence, we have 4 lots of 28. In the second one, we have 20 lots of 4 and 8 lots of 4. So that actually is the equivalent of 28 lots of 4, isn't it? Because we have 20 lots of 4 and we also have 8 lots of 4. So that would also work. In this one, we have 4 lots of 20 and then just 8. Okay, we need 4 lots of 28. So we've got our 4 lots of 20. We don't have our 4 lots of 8. We've just got 4 lots of 20. The one above it, it was partitioned. This one has been partitioned, but they haven't got the 4 lots of 8. So that one is not one. You could put a cross next to it. You could just leave it blank, cross out, whatever you want to do. This one we have 4 lots of 30 and we're taking away 4 lots of 2. So this is the same as 4 lots of 28 because we had 30 lots of 4, 4 times 30, and then we're subtracting 2 of those groups of 4. That is the same as 28 lots of 4, or 4 times 28. And then here we have 4 lots of 30, but we're just taking away 2. So you can see the difference between these two and these two. This is partition, this one isn't. It's just, this is 4 lots of 30, take away 2, not take away 4 lots of 2. So that is not correct. Question 14. This table shows the distances Kirsty cycled last week, and you can see we have a table with our days down the left hand side, Monday to Friday, and then across the top our headings show some of her journeys. We've got from home to school and then the return from school to home. They're obviously the same distance, and from school to tennis and from tennis to home. So the question is, what is the total distance Kirsty cycled last week? We need to consider all of these journeys that are ticked. So it tells us on Monday she just went to and from school, same as Tuesday, but on Wednesday and Friday she also went to tennis, and Thursday it was just home and school as well. So there are a few different ways you could do this. You could either total up your columns or you could total up your rows. So to total up your columns, you might look at how many times did she cycle from home to school, the 4.3 miles. So she cycled from home to school every day. So you might total down here 5 lots of 4.3. she only cycled from school to home 3 times. So you would at the bottom cycle total that bit up. Then on 2 days of the week she cycled from school to tennis, and then she cycled from tennis to home. So you can see on Wednesday and Friday after school she didn't cycle home, she went to tennis and then she cycled home. So you could either do the totals at the end of the columns, or you could do the totals at the end of the rows, or you could total up how many 4.3 miles there are, how many 2.6 miles there are, and how many 3.1 miles there are. So for example, 4.3 miles, that's the home to school and vice versa journey. There are 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 lots of 4.3. So I could just start writing down some of my calculations. Even if I don't actually calculate them, I could just start writing them down. So there are 1, 2, 3, 4, 5, 6, 7, 8 lots of 4.3. There are 2 lots of 2.6. And there are 2 lots of 3.1. So 3.1 times 2. So we could write down the totals there, then add them up. Or like I say, you could do each column or each row. So if I was to do the home to school column, that's 5 lots of 4.3. I'm not going to demonstrate how to calculate. I'm going to assume you know how to calculate. I'm just going to write the answer in. So that would be 21.5. My 3 lots of 4.3 would be 12.9. My 2 lots of 2.6 would be 5.2, and my 2 lots of 3.1 would be 6.2. So that's one way you could do it, and then you could add up these totals, write your answer in. Or you could do, if I do it in a different colour, you could do your columns. So Monday 8.6, because it's 2 lots of 4.3. So I know that is the same for Tuesday and the same for Thursday. On Wednesday we have 4.3 plus 2.6 plus 3.1. That adds up to 10, and I know Friday is the same. You could add those amounts up, 8.6 plus 8.6 plus 10 plus 8.6 plus 10, or 3 lots of 8.6 plus 2 lots of 10. They should all, well, it will all end up as the same total. If you are doing decimals, then you may be doing your calculations like this. So 4.43 times 8, calculating it. And then putting your decimal point in afterwards. Hopefully you can double things in your head, so 2.6 and 3.1 multiplied by 2, hopefully you can do that. And then adding them here. So this one is the same as doing this bottom row, but the 4.3 times 8 is combined. Here we've got 21.5 and 12.9, so that's 5 lots of 4.3 and 3 lots of 4.3. If you add these two numbers together, you'll get this 34.4, this 4.3 times 8. If you did the days of the week, it would have been slightly different, because you would have been doing 8.6 times 3, and then you would have done 10 times 2. So you know 10 times 2 is 20, and then you would have done your 8.6 times 3. You may be able to do that in your head, or you may have done 86 times 3. And then put your decimal point back in. And then you add them up. So if I now choose another colour again, if I went to this one, I've got 8, 15, 4, and if I went to this one, and it's not lined up perfectly, I've still got the same answer. Any way I do it, I've got 45.8 miles. Please do show your calculation. If you do total up the columns and the rows, don't just leave it like that and add them up. Make sure you write down what calculation you're doing. So it could have been this one here on the left, or it could have been this one here, just show what you're doing. Just labeling the columns isn't enough to show what your intent is. So even if you wrote 8.6 times 3, 10 times 2, then added up your answers and you got the wrong answer, you could still pick up a method mark depending on the mark scheme that year. And the same with this one. If you'd written 4.3 times 8, 2.6 times 2, 3.1 times 2, even if you got some of your answers wrong, as long as you added it all up and showed what you were doing with your numbers, then you could get a method mark. So these are a few different ways to answer that question. Question 15, here is a diagram made from regular hexagons. What percentage of the diagram is shaded? Now it's telling us that they are regular, so that we know they're all the same size, so we don't have to worry about figuring out if any of the hexagons are bigger than the other. We know that it's like a fair picture. When we are looking at percentages, we always want to know what we have out of the total. So we're going to think about it as a fraction first. The first thing I would do is count how many hexagons there are in total. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we know that it's going to be a fraction out of 10. So let's figure out it as a fraction first. And then if we count how many hexagons are shaded, we've got 1, 2, 3, 4, 4.5. And now this is important because it is quite easy to look at this diagram and to immediately think it looks like half, because it is very close to half, but it is not quite half. If it had have been half, there would have been 5 shaded out of 10. 5 shaded out of 10, or 4.5 out of 9, but there is 4.5 out of 10. So we need to convert this to a fraction over 100. Now obviously when we do fractions we don't work with decimals as part of the fraction, but we're converting this to a percentage. So there are 4.5 shaded out of 10. So to find it as a percentage, percentages are fractions out of 100. So we need to think about what we're going to scale up by. So to get from 10 to 100, I'm going to multiply by 10. So I'm just going to multiply that numerator by 10 as well. So I'm going to multiply this 4.5 by 10, which is 45. That now gives me my percentage. It is 45% shaded. So find it as a fraction and convert it to a fraction out of 100, and that will give you your percentage. Question 16. Here are 2 boxes, and you can see that we have 2 boxes drawn. Please do not ever worry about trying to measure with a ruler. Assume that things are not to scale. It doesn't actually say not to scale on here, but do not use the size of them on the page to try and help you answer the question. Only use the information that's given. It tells us that the mass of the first box is 1.25 kilograms and the second box is 1.4 kilograms. So you can already see that we've got one represented with fractions, one represented with decimals. So for this we need to understand how to convert between fractions, decimals and percentages. What is the difference in mass of the 2 boxes? So this bit's important. What is the difference in mass of the 2 boxes? Because we need to know what we're doing with this information. What answer are they're looking for? They're looking for the difference between the 2. So to find the difference between the 2, we first of all need to know what the 2 boxes are in the same unit. So either both as fractions or both as decimals. So we would really want to be changing this to decimals would be better. You don't have to do it as decimals. This could be an answer in fractions. An answer in fractions was accepted in this mark scheme, but as it wants the answer in kilograms, I would convert both to kilograms. So first of all, 1.25 kilograms, we'd need to know that the 1 kilogram, I'm just going to write here, 1 kilogram equals 1,000 grams. And the reason why I'm writing it in grams is because we've got a whole, in both boxes there's 1 whole kilogram, but then there's a part of a kilogram. So part of a kilogram is going to be in grams. 1/4 of a kilogram is equal to 250 grams. Okay, 1/4 is a half of a half. So this first box, 1.25, I would write at the top. So if we added those together, it is 1,250 grams or 1.25 kilograms. Those are both the same thing. Now we know this is 1.4 kilograms, so we could already work with the 2 of these because we've got 2 in the same unit, or you could also convert this to grams. 1.4 kilograms is, so I could write again, I've got my 1 kilogram, 0.4 kilograms is equal to 400 grams. So this is 1400 grams. Now I can either find the difference between these two, so I could do 1400 take away 1250, which is 150 grams, or I could do 1.4 subtract 1.25. I put a 0 there. I always make sure my decimal we have the same amount of decimal places, especially when subtracting, otherwise it's very easy to make an error there. You will see that you can see the similarities. If we did the 1.4 take away 1.25, you're already going to have your answer in kilograms. If you do it in grams, you need to make sure that you convert that answer to kilograms. It asks for the answer in kilograms. There's also the kilogram symbol in the box. So if you wrote 150 in here, it wouldn't be the right answer. The answer is 0.15 kilograms. So you must make sure that you write it in. If you're not sure, if you really don't know how to convert it, leave your answer in grams on the page. You know, you could cross out the kilograms and write grams in. I wouldn't suggest that unless you really don't know how to convert it. But make sure you write in the correct number that corresponds to the unit, the kilograms that they are asking for, and that is shown in the answer box. If there is no unit shown in this answer box, you would either write 0.15 then add your kilograms, or 150 and add your grams. Question 17. A 4 kilogram bag of rice costs £6. What is the cost of 500 grams of the rice? So there are a couple of different ways to do this. I'm going to show you how I would do it. First of all, you need to recognise grams to your kilograms, and we want to convert them to the same unit. So we know what 4 kilograms is worth. I'm just going to write here again, 4 kilograms is £6. Now I would change this to 1 kilogram. Because I know that 1 kilogram is just 2 lots of this 500 grams, I can just halve this once I've got the answer. So to change this £6 to what 1 kilogram is worth, I'm going to use the idea of ratio here. I'm just dividing by 4. So I'm just going to divide that by 4. Now you can use a bus stop method, or to divide by 4, it's just halving and halving again. Half of 6 is 3, and half of 3 is £1.50. So 1 kilogram bag is worth £1.50. So 500 grams, again using the idea of ratio, to get from 1 kilogram to 500 grams, I'm just dividing it by 2, I'm just halving it. So I'm just going to halve that as well, that £1.50, and half of £1.50 is 75p. Now you need to either write it as £0.75 or as 75 pence. Note it doesn't have any units in the box, so you must make sure whatever you put in that you specify. So you're either putting in 75 pence or you're putting in £0.75. I would not recommend that you put two things in the box, because if you accidentally wrote one of these wrong, it kind of cancels out the correct answer. Question 18. Tick the fractions that are greater than 2/3. Okay, you can see down here we have fractions in different denominations. So what I would do is I would just be writing the equivalent of 2/3 with those denominators. So if I just made a list at the bottom, I'm going to write my 2/3 is equal to 4/6. So I'm just doubling the denominator. We've also got a 9 there, so 3 times 3 is 9, so 2 times 3 is 6/9. And we've also got a 12 in there. So I'm just going to write down all the denominators that I need first. And then if I go back to the original, so 3 to 12 is times 4. So 2 times 4 is 8. 3 to 15 is times 5. 2 times 5 is 10. And 3 to 21 is times 7. And 2 times 7 is 14. You could also have just added in 2s and then added in a 12 over 18 as well. We didn't need it though, so I've just been more efficient by writing what I need. Now that I know what 2/3 is equal to in all of these denominators, I can tell whether these are bigger or not. So is 5/6 greater than 4/6? Yes, it is, so I can tick that. Is 4/9 greater than 6/9? No, it's not. Is 9/12 greater than 8/12? Yes, it is. Is 11/15 greater than 10/15? Yes, it is. Is 10/21 bigger than 14/21? No, it's not. So by very quickly just jotting down my equivalent fractions, I can just really quickly go down and tick, 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 tick. I haven't got to keep doing each individual calculation. It's really quick just to write a list of equivalent fractions and then use that to compare. Question 19. The total cost of a school trip for 12 pupils is £780. The total cost includes travel, food and hotel. For one pupil, the travel cost is 27 and the food cost is 16. How much is the hotel cost for one pupil? Okay, so we're given the total for everyone. We know that it consists of 3 categories, and we're told how much 2 of those categories cost for one person. We need to find out the 3rd category. So there are a couple of different ways to do this. One way would be to find the total cost for one pupil. So we know travel and food, but we don't know the total cost for one person. So that would be to take your 780 and divide that by 12. I'm just going to write down the calculations we could do first rather than showing the calculations. So we could get that, and let's say the answer to that was A. Once we've got that, we can then subtract the travel and the food cost. So we could do 27 plus 16 equals B. So that gives me my travel and my food cost, and then we would do A subtract B. So the answer to A subtract the answer to B, and that will give you your hotel cost. That's one way to do it, and I will do that calculation in a moment. And the other way to do it would be to calculate the total travel cost for the total cost for travel and the total cost for food. So we've got one pupil, and we know there are 12 pupils. So you could do 27 times 12, and then you could find 16 times 12. So let's just say this gives you answer A, this gives you answer B. Add A and B together, that gives you answer C. And then you would do 780 subtract your answer C. That gives you answer D, and then answer D divided by 12. So either one of those works. I'm going to go back and do it the first way. In fact, I'll do it both ways. I'll do it this way first. So 21, I'm not going to go through the whole extended calculation, I'm just going to write the answer in. So 27 times 12 is 324, and 16 times 12 is 192. So that is my 12 pupils for travel and food. So now I would do 324 plus 192, and that is going to give me 12 people's cost for travel and food. If I subtract that for the total costs, so 780 take away my 516, and that gives me 12 pupils cost for the hotel. 12 pupils cost for the hotel. So the final step would be I need to divide 12 pupils cost for the hotel by 12 to find one person's cost. And the answer would be £22. Now if I do it the other way, which I personally think is a lot quicker, I would be doing, first of all, 780 divided by 12. So 12 into 7 obviously doesn't go. 12 into 72 I know goes 6 times, so 12 times 6 is 72. There is a remainder of 6, and 12 into 60 goes 5. So each person's travel costs £65. Now if I add up what each person's total cost is £65. If I now work out what the travel and food cost together is, so 27 plus 16 is 43. So I know that each pupil's total cost is £65 and their food and travel cost 43. So if I do 65 subtract 43, that will tell me what the difference is. That tells me what the hotel part of it is. 5 take away 3 is 2, 6 take away 4 is 2, and look, it's the same answer. I personally think this way is quicker, but both of the methods get you to the right answer. Please do write every single part of your working out, and if you get something wrong, there's plenty of space to do working out elsewhere on the page. Question 20. Sophie thinks of two prime numbers, so it's in bold, there's two of them, and then both numbers need to be prime numbers. She adds them together, her answer is 24. Write all of the different pairs of prime numbers that Sophie could think of. So all is in bold, which means we need to find all of the possibilities. This question is worth 2 marks. First of all, for this question, I would be making a list of prime numbers. We know that the prime numbers are not going to be greater than 24 because the two numbers add together to make 24. So we're going to start by just making a list of prime numbers that are less than 24. So this is one of the things you need to know. So 1 is not a prime number, 2 is a prime number, 3, 5, 7, 11, 13, 17, 19 and 23. These are your prime numbers. If you're not sure on prime numbers, then that's something that you could look up. Look up the prime numbers to 100. Use 100 square to locate your prime numbers. But if this is something you're not sure of, you don't know, then that is something you need to learn. Now we can just look at those and see what would make 24. So you could work by a process of elimination. So for example, 2 would need to add to 22, we don't have a 22. 23 would need to add to a 1, we don't have a 1. 19 would need to add to 5, we have that. So 5 and 19. 3 would need to add to a 21, 7 would need to add to a 7, sorry, I crossed out the 3. 7 would need to add to a 17, we've got that. And 11 would need to add to 13, and we have those. So we know that we have all the right numbers because as we've written all our numbers down and eliminated the ones that work and don't, we've used up exactly the list of numbers that we had. Question 21. The mass of a 1p coin is 3.56 grams. The mass of a 10p coin is 6.5 grams. The coins are illustrated. What is the difference in mass between £1 in 1p coins and £1 in 10p coins? This is a 2-mark question and you need to show your method. It means that a method mark is available. So first of all, the pictures are there just simply for illustration. The mass of a 1p coin is 3.56 and we need to know what the difference is between both of these coins if we had £1 worth of both of these coins. So first of all, how many of the 1p coins would we need to make a pound? So we know that the 1p coin, 1p fits with, there's 100 pennies in a pound, so we know that we're going to have to multiply this by 100. I'm going to annotate it there. 10p coins, how many 10p coins would we need to make up a pound? Because we need to find a pound in both. I know that I would need 10 coins, so I would jot that down there just to sort of remind me that's what I'm doing. So I now know that because I need 100 1p coins, I can do this calculation. So I'm going to just jot out the calculations rather than calculating it for the moment. So 3.56 times 100, that's going to give me answer A. Then I would do 6.5 times by 10, that's going to give me answer B. And then I would, depending on which one is the greatest out of A and B, I would find the difference. So if A is greater, I would do A subtract B. If B is greater, I would do B subtract A. So I'm actually going to just calculate this in my head. There's various different ways, methods you can use to calculate. You could remove the decimals and then divide after. but hopefully you know how to multiply by 10 and 100. That is something that you are expected to know in year 6. So if I'm timesing by 100, each of my digits is going to increase to the power of 10 by twice. So it's going to go on a place value chart, they'd move to the left twice, so my 3 is going to become 300. My digits always stay together. When you multiply by powers of 10, so 10, 100, 1,000, your digits stay together. They just move by 1, 2, 3 spaces depending on your number. So 100, it moves 2 spaces. 6.5 times 10 means I'm going to increase each digit by 1 place. So my 6 will become a 60, my 0.5 will become a 5. So this will be 65. So I now know that my 1p coins are worth 356 grams and my 10p coins are worth 65 grams. I need to find the difference between them. So you might use a number line. I'm not using a straight line here. 65, 356, and find the difference in between. However you want to do that, I would go up to 100, then to 300, and I would be finding the difference there, finding the difference there, and finding the difference there, then adding them all up. Or you could simply do 356 subtract 65 using the formal written method. So that's 1, and then 35 take away 6 is 29. So the answer is 291 grams. If you did it this way down the bottom, 65 to 100 is 35, 100 to 300 is 200, and 300 to 356 is 56. If I added this all together, 35 and 256, I would also get 291 grams. That's worth 2 marks. If you just calculated this bit, if you just showed your understanding that 1p was worth 356 grams and that the 10p's were worth 65 grams, in this year you would have got a mark just for showing that bit, and subtracting them. Actually, in this exam you would have got it just for showing that bit. They could have also wanted to see this bit. If you got this bit wrong, like the answer to this, you would have needed to show the next step, which is to find the difference. Question 22, calculate the volume of this cuboid. To find volumes of cuboids, you multiply the 3 dimensions. So you are doing 2 times 12 times 1.5 or 1.5. When you are multiplying, you could either do 2 times 12, then times that by 1.5, or you can combine any of these. So for example, I could choose to do my 2 times 1.5 first because I know that is 3. So I could then change this calculation to 3 times 12, which is 36. You could have done 2 times 12 is 24, 24 times 1.5 is 36. If you're not sure how to multiply by decimals, then that is something you should revise, but you can partition this, you can multiply it by the 1, multiply it by the half, add them together. But the answer to this is 36 centimetres cubed. Centimetres cubed is already written in there. If it wasn't written in the box, you would need to make sure you wrote centimetres cubed. That cube symbol shows that it is a volume rather than an area. Question 23. The distance from A to B is 3/4 of the distance from A to C. What is the distance from B to C? And this is a 1 mark question. So you have a number line and we've got that the first bit is labelled. So the distance from A to B is 3/4. Now with questions like this, I like to label. So this is 3/4 of A to C. Well, if that is 3/4 of the whole distance, what must the remaining bit be? Well, the remaining bit must be 1/4, because I know that 3/4 plus 1/4 makes 4/4, which is the whole distance. Now, if we know that 24 kilometers is 3 of the quarters, that can help us to find 1/4. Because if this is 3 of the quarters, we can simply divide this 24 kilometers up by 3 to find what each quarter is worth. Now, this is a bit like a bar model. If I did that, this is obviously not using a ruler. I know that this is 3, the 3/4, that's the quarter. I know that that's worth 24, and I know that these are all quarters. So I've got my 4 quarters, and I know that 3 of the quarters are worth 24 together. If we divide our 24 up by 3, we get 8. 8, 8 and 8. So that tells us what the quarter is. So I can actually fill in my final box with 8 as well, which is the answer to the question. The question wants to know what B to C is, what this bit is. So this bit is 8. It's not asking us what the total distance is, so we do need to be careful in questions like this when we're calculating things that we answer the actual question they're asking us. So the distance from B to C is 8 kilometers. I hope you found this video really useful. Remember to like and subscribe so you can watch more videos where I show how to answer the questions from the past SATs papers. And if you are looking for more SAT support, then head over to pocketprivatetutor.co.uk, where I have tons of courses and resources to help you feel confident.